Good evening, everyone. Today we are going to discuss about a topic that is nothing but chemical kinetics. So here, as the name suggests, what we are exactly going to learn in the chemical kinetics is, see, you might have studied about the thermodynamics. So thermodynamics generally tells us about whether a particular reaction is going to take place or not. By knowing the Gibbs free energy, that is whether a reaction will be spontaneous or not, can be given by the can be find out with the help of the chemical thermodynamics. In chemical kinetics, what we are going to learn as kinetics. So kinetics is nothing but the word something related to the rate, or we can say speed, rate or the speed. So in chemical kinetics, we are going to learn about what is rate, how to find out rate or a speed of any chemical reaction, and what are the different factors that are going to affect on the rate or a speed of a chemical reaction. Now, let's consider about any reaction. Just like I'm talking about a reaction in which a reactant R is converting into P here. So generally when we say the rate or a speed, what we know about rate or a speed, generally rate is a distance traveled divided by the time taken. But when I say any chemical reaction where the reactants is converting into product, what we need to discuss here, we are talking about change. Now, as a speed is change, that is how what amount of distance you have traveled divided by the time in which you are covering the distance. Similarly, when the reactants converts to the product, there is change in the concentration. So in a chemical reaction, we are discussing with change in concentrations, change in the concentration of the reactant or the concentration of the product. So now we are going to discuss about what exactly the rate of chemical reaction stands for. So when I'm talking about the rate of the chemical reaction is defined as change in the concentration or pressure. Now when we say the pressure is generally related for the gaseous reactant. So when the reactants are in the gaseous form or a product is present in the gaseous form, we can say we can define the rate in terms of pressure. So the change in concentration or a change in pressure of reactant or a product per unit time will be considered as the rate of reaction. Now see, let's discuss how we can find a rate of reaction. Let's we have a reaction in which the reactant R converts into P. Now we know that at time t is equals to 0, what is going to happen at time t is equals to 0? We will only have a reactant. Okay, we will only have a reactant. So let's consider I'm taking particular amount of reactant with a concentration 100 mole per liter. Okay, so initially I have taken 100 mole per liter concentration of the reactant. As the time proceeds, what will happen? As the time proceeds, the concentration of the reactant is going to decrease. Why the concentration of the reactant is going to decrease? We know that the reactant is going to start reacting and will convert into the product. So at any time t is equals to t, at any time t is equals to 0, let's consider 5 minutes, 5 seconds, 50 minutes, whatever it is. What will happen? The reactants start reacting and it will convert into product. So at time t is equals to t, the reactants change, there will be change in the concentration, it will be decrease the concentration. Let's consider at time t is equals to t is reduced to 60 mole per liter. 60 mole per liter. Now see what we are finding here. We are going to define the rate of reaction. Now see here, the reactant concentration is changes from 100 mole per liter to 60 mole per liter, right? Similarly, what will happen with the product? At time t is equals to 0, there will be no product. It means 0 mole per liter will be present. But as soon as the time proceeds, the reactants started reacting and it converts into product. It means the concentration of the product is going to increase, right? Means we can say the 100 mole of reactant is changes to 60 mole, means the product which is 0 mole at an initial time is going to form how much? 40 mole per liter. When I can say that? When there is 100% completion, or we can say when the reactants is completely converted into the product. So here out of 100, 60 is remaining, is what amount product will be formed? 40 mole per liter is formed. Now see, very important here. The rate of the reaction can be defined as change in concentration. So here the concentration of reactant, what it is decreases, right? Similarly, the point to be noted here is that the concentration of product is increases. Always the same thing is going to happen. The reactant concentration is going to decrease and the concentration of the product will increases. So how much amount of concentration of reactant or the concentration of product changes with respect to the time is called as the rate of reaction. See, we can write rate of any chemical reaction. It can be written in the form like that. Yes, it is change change in concentration. So we are carrying out the change. Okay, so how will you write the change? Change is nothing but final concentration minus initial concentration. Now see here, what is this final? RF stands for final concentration of reactant. What is RI? RI is the initial concentration divided by time. The final time I'm taking T and initial time, that is 0. So here this is change. So we are generally writing the change final minus initial. Now here point to be noted. See here it is written that it is always a positive quantity. So if I want to find out rate of reaction here, my final quantity is 60. Initial quantity of the reactant was 100 divided by, let's consider the time, and time t is equals to, let's consider this is 10 minute. I'm taking 10 minutes, that is 10 minus 0. So we are getting some negative value, that is minus 40 divided by 10. But is it possible that I cannot say like that I'm running with the speed of minus 20 meter per second? No, it is totally wrong. So speed of the reaction can never be negative. Speed of the reaction can never be negative. So to remove that, what we are going to do, whenever there is a reactant, the reactant concentration decreases. To make it positive, we are going to apply one minus symbol here, so that the rate should be positive. The rate can never be a negative. Okay, so here why I have put this negative symbol? The negative symbol simply tells us about, yes, what it is, the rate, that is the concentration of the reactant decreases and rate cannot be a negative quantity. So this is how to find out a rate. Let's consider go with the product. So now products, how will you write the product rate? So rate of reaction with respect to product, we can write like final concentration of product minus initial concentration of product divided by time. Okay, change in time is t minus 0. So initially there was 0 product, that is 0 mole per liter, and then changes to 40 as we have discussed in the example. So the final concentration is 40 now and initial concentration is 0 divided by time 10 minus 0. So here also we are going to get a value, that is we can write 40 by 10, which is nothing but 4, okay, mole per liter per second. Okay, we will discuss now what will be unit of reaction, rate of reaction also. See, so here what we have derived, we have simply says what is rate of reaction is simply the change in concentration of reactant or a product with respect to time. Now, the point to be noted here is that the when we consider the reactant, its concentration decreases. And when we say the product concentration increases. Already we have discussed this. Now, what I mean to say here, there we need to discuss two rate. One is rate of disappearance, and other is nothing but the rate of appearance. Now, see what I'm going to say here. If I have a reaction rate, that is reaction in which the reactant R converts into P, what is happening? The concentration of reactants decreases. It means reactants start disappearing. So I can write like this also, rate of disappearance of rate of disappearance of R. The R is disappearing, reactant is disappearing, is nothing but equals to what is change in concentration. Okay, so I'm writing the change. I'm representing this with the help of delta, that is change in the concentration of reactant divided by change in time representing by delta. Now already we have discussed this, is that the concentration of reactants decreases So we are going to get this change negative, but rate cannot be a negative value. So we are going to maintain this negative at the starting so that the rate should be positive. Okay, or we can say this negative symbol represent there is decrement in the concentration of reactant. Similarly, the concentration of product increases. So if I'm going to write the rate of appearance of P. Why I'm saying appearance? Because product is forming, the product is appearing. So we can write like this: rate of appearance of P is nothing but change in concentration of product divided by change in time. I need not to write here anything negative. Why? Because product concentration increases. So anyhow, this rate this rate is going to be positive only. So here we got how to write rate of disappearance of a reactant and rate of appearance of the product. Okay, now let's talk about what will be the unit. So first we'll discuss about what is unit of rate, then we'll go for the types of the rate of reaction. So simply first we'll talk about the unit of the rate. Now see here, unit of rate of reaction, rate of reaction. Now we know that rate of reaction is simply what? Change in concentration of reactant or a product divided by change in time. Change in time. Now, the concentration generally we are representing with what? Concentration we represent with the help of mole per liter. Okay, it is mole per liter, and time we can represent either maybe in second, maybe in hour, maybe in minute. So the unit for rate can be written as concentration is mole per liter, this is mole per liter, and divided by time. Now what is time? Time may be in seconds, so I'm writing, let's consider second or any time unit of time. So the general unit of rate of reaction can be mole liter inverse second inverse, or we can write mole liter inverse minute in hours, or we can write it as mole liter inverse and hour inverse. It depends upon what unit of time you are taking. Okay, so this is about the unit of rate of a chemical reaction. So till now we have discussed how to find the rate of reaction, what is rate of disappearance, what is rate of appearance, and what is the unit of rate of a chemical reaction. Now let's discuss about what are the different types of rate of reaction, how we can represent the rate in the different form, right? So we can represent the rate in the two form. One is called as average rate of reaction, another is nothing but the instantaneous rate. So first we'll talk about what is average rate of a reaction. Now see here, very important, as the name says, everything itself in the average. Now let's consider, if I'm going to travel from one point to another point, let's consider this point A to point B, right? And this distance is nearly 10 kilometer, is nearly 10 kilometer. So if I have covered this distance, if I covered this distance in 5 minutes, if I cover this complete distance in 5 minutes, so how I'm going to find out the average rate? Average rate can be find out about how much amount of distance I traveled, that is 10 kilometer, divided by how much amount of time I have taken, 5 minutes. It means if I want to find out average speed of this travel, is simply the distance I have traveled divided by 5, that is nothing but 2 kilometer per minute. So I'm covering 2 kilometer per minute. Is it like so my speed will be always 2 kilometer per minute during the rate of the reaction? No, it may change. That is, sometime I may be running with the speed of 1.5 kilometer per minute, or less than that, or more than that. So, but when I'm saying average, so we are calculating the average over a particular period of time. Similarly, when I'm talking about a chemical reaction in which the reactant is converting into product, okay, if I want to find out the average rate, what I'm going to do, I will take the final concentration over a particular range of a period, that is 0 to 10 minutes, it may be 0 to 5 minutes, it may be 0 to 1 minute, it may be 10 to 15 minutes, that is particular range of the range of time. So what it is, the rate of reaction over a certain measurable period of a time during the course of reaction, it is called as the average rate of reaction. Okay, it is the rate over what, over a particular measurable time period. Okay, that is the rate, average rate. And this, when we talk about the average rate, it is represented by what, it is represented by delta, it is represented by delta. So how will you write the average rate? Average rate of the reaction, we can write the average rate of a reaction, that will be equals to change in concentration of reactant, this is over the particular period of time, change in time. As it is a reactant, we can write minus. Okay, similarly, change in concentration of product divided by change in time. So this is the average. Average means over a particular measurable period of a time. It may be 0 to 10 minutes, it may be 10 to 15 minutes or anything. It is fixed period of a time. Second is instantaneous rate. Now instant, something related to a particular instant. So as I discussed now, that is this distance I have traveled, 10 kilometers distance I have traveled in 5 minutes, in 5 minutes. Now it is not like that every time I'm traveling with the speed of 2 kilometers per minute. Sometime my speed may be, okay, at the initial point there may be some traffic, so I may have decreased my speed, or when there was no one present, or when the traffic was less, I may have increased the speed. It means my speed is continuously changing. But let us consider at a particular distance, if I ask what is your speed, what is my speed at 2.2 minute, or we can consider what is my speed at 2.20 second. Means what I'm doing here, I'm not asking the average speed, I'm asking the speed when I'm traveling, exact speed at particular instant, that is 2 minute 20 second. So what I'm going to do, I'm going to check my speedometer exactly at what time. I'm going to check my speedometer exactly at 2 minute 20 second, and at that time what will be my speed, that will be called as instantaneous speed. Let us consider simple one more example. Let's consider I'm driving a bicycle. Okay, and if you call me and yes, you are going to ask at what speed you are going, at what speed you are going, I will see my speedometer. Yes, I'm going with a 40 kilometer per hour at a particular instant. So the rate of, similarly, what is the instantaneous rate of reaction? The rate of a reaction at a particular instant during the course of reaction. So if this reaction reactants convert into product, it takes 40 minutes for the completion. Okay. Now if I ask you what is the speed of a reaction at 2 minutes 20 seconds, so at exactly 2 minutes 20 seconds, what will be the rate? That will be called as instantaneous rate. Now I'm not asking over a range of period. I'm asking exactly at a particular instant. So when the when we are calculating the rate exactly at a particular instant, that will be called as the instantaneous rate. And the instantaneous rate is generally denoted by D. Now this is differential form. So how we are going to write this? So rate will be minus of dr divided by dt, or dp divided by dt. This is the instantaneous rate of a reaction, right? So instantaneous rate is the rate at a particular instant, while the average rate is nothing but the rate over a certain period of a time. Okay, I hope you got this. Now we will discuss one example how to find the rate. Okay, rate of appearance, rate of disappearance, and the rate of a complete reaction. Now let's consider we have a reaction, a very famous process, that is the Haber's process. Okay, in which the nitrogen is combines with the hydrogen, okay, and going to form an ammonia. The process name is a Haber's process. So this is a reaction we are having. So for this, let's consider if I want to find what is rate of what, the rate of disappearance, rate of disappearance of nitrogen. So how will you find the rate of disappearance of nitrogen? What it is? Simply change in concentration. So the change in concentration of nitrogen, okay, over a particular period of a time, that is change in time. I am writing minus. Why I am writing minus? As we know, the nitrogen concentration is going to decrease, so this change will be negative, and we want rate as a positive. Rate cannot be a negative value. Similarly, if I want to write the rate of disappearance of disappearance of hydrogen, okay, now when the hydrogen also reactant, it is also going to change, it is also going to decrease, its concentration will decreases with the time, right? So we will have, just a second. So we will have change in concentration of hydrogen divided by change in time, right? This is a disappearance. What is NH3? Ammonia. Ammonia is a product, it is going to form. So we'll write rate of formation, rate of formation, or we can say like that also, rate of appearance of ammonia. It is what is change in concentration of ammonia divided by change in time. So this is how to write the rate of disappearance or appearance or a formation of any chemical reaction, right? So this is rate of disappearance or appearance. Now we will write the rate of reaction in form of stoichiometry of any chemical reaction. Generally, we have seen many examples where we will have a stoichiometry. Just now we have discussed one example where 1 mole of nitrogens combines with the 3 moles of hydrogens, and 2 more, it is going to form 2 mole of ammonia. So this number, that is nothing, here we are having 1, this 3, and this is 2. So this 1, 3, 2, this number are nothing but what? These are the stoichiometry coefficient of a chemical reaction. So how we are going to write if the stoichiometry is given? So for any reaction, if we are having any reaction like A of A plus B of B, A of A plus B of B gives you C of C and D of D. Here I can write, or I can read this reaction as A moles of reactant A is combines with B moles of reactant B, going to give you C moles of reactant C and D moles of reactant D, sorry, D moles of product C and D moles of C moles of product C, right? So C and D are nothing but the products, while A and B are the reactant. Now see, when I'm writing its rate, okay, when I'm going to write the rate, so the rate of reaction in form of stoichiometric coefficient. I'm not saying now the rate of disappearance or rate of appearance. I'm talking about complete rate of a reaction, okay, or we can say the average rate of reaction. Okay, how will you write the average rate of reaction? Okay, we can write the average rate of reaction is simply like minus 1 upon A change in concentration of the reactant divided by change in time. Now why I'm putting minus symbol? Because yes, the reactant concentration decreases, is nothing but equals to change in concentration of B divided by change in time. I'm putting what? I'm placing this stoichiometric coefficient at the bottom with the representing the symbol minus, because as it is a reactant. It can be written in the form of product also. As product is going to form C, I'm taking its coefficient at the bottom with the change in concentration of C divided by change in time. Similarly, for the product D, it will be 1 by D. The stoichiometric coefficient will be in the denominator, change in concentration of D divided by change in time. So this is how to represent the average rate of reaction. It is average rate of reaction for any reaction in this stoichiometric coefficient. Now, just now we have discussed this reaction, N2 plus thrice of H2 gives you twice of NH3. So if I have to write the average rate, okay, if I have to write the average rate of reaction, previously we have discussed the rate of disappearance with respect to particular reactant, rate of appearance with respect to particular product. Now this is the average rate. An average rate can be written in the form of any reactant or product. So see, very important point. Average rate will be equals to what? Minus 1 by 1. Now from where we are getting this one? We are having a stoichiometric coefficient is 1. Change in concentration of nitrogen divided by change in time, that will be equals to, okay, because whether I'm representing the rate with respect to the nitrogen or with respect to hydrogen, it should be same always. Okay, it will be minus 1 by 3. The stoichiometric coefficient will be at the bottom. Change in concentration of reactant divided by change in time will be equals to what it is, product. So product will be representing with the positive symbol itself. Okay, change in concentration of ammonia divided by change in time. So this is how to represent any rate of the reaction, average rate of the reaction with their stoichiometric coefficient. Okay, so this is how to find the average rate. Now let's see some questions. If I have some question like twice of HI gives you H2 plus I2. Let's consider this reaction. Okay, in this reaction, if I ask you to write rate of disappearance appearance of HI. Why? Because hydrogen iodide iodide is nothing but what, a reactant, and it is going to decrease. So that's why it is a rate of disappearance. So when I'm writing disappearance, I only need to write what? I only need to write change. I will not represent the stoichiometric coefficient in rate of disappearance or rate of appearance. I will only represent the stoichiometric coefficient when there is an average rate of a reaction. So what is the rate of disappearance? Only change in concentration. So write change in concentration of the reactant divided by change in time. Okay. Similarly, if I want to find out what is the rate of formation, so rate of formation of hydrogen. How will you find the rate of formation of hydrogen? Change in concentration of hydrogen divided by change in time. Okay. Now one very important point I need to focus here, that I'm not representing here the stoichiometric coefficient. Why? Because we are only writing the rate of a particular reactant or a particular product. This is not the average rate. It is rate with respect to particular reactant or particular product. Okay. Similarly, rate of formation of I2 will be what? It will be change in concentration of I2 divided by change in time. Now focus. If I need to write now rate of, okay, rate of reaction. Now this is a rate of complete reaction. It is not with respect to particular reactant or product. So what it is? Average rate of a reaction will be is equals to what? It is minus 1 by 2 stoichiometric coefficient, change in concentration divided by change in time. Similarly, now move toward the product. So it is 1 by 1 change in concentration of hydrogen divided by change in time. That is equals to change in concentration of I2 divided by change in time. This is how to write the rate of disappearance, rate of formation, and average rate of any chemical reaction that is given to you. Okay, we'll discuss one question here. See here. We have a reaction twice of N2O5 gives you 4 of NO2 plus O2. If the concentration of NO2 is decreased by 1.6 into 10 to the power of minus 2 molar in 4 seconds, we need to calculate the following. Okay, again, for a reaction twice of N2O5 gives you 4 of NO2 plus O2. What they have given? They have given that the concentration of NO2 is increased. It is increased by 1.6. It means they have given this change. So they have given the change in concentration of NO2 over a particular range of a time, that is 4 seconds. We need to write what is the rate of formation of NO2. Okay, so how will you write rate of formation of NO2? So if I want to write the rate of formation of NO2, it will be simply as what? Change in concentration of NO2 divided by change in time. So see here, change in concentration of NO2 divided by change in time. This is rate of formation of NO2. Why I'm not representing minus symbol here? Because itself it is a product. So for product we will not write the minus symbol. Okay, this value will be positive. They have itself given what? The concentration is increased. So what is change? The change which is given is 1.6 into 10 to the power of minus 2. How much time? In 4 seconds. So it will be 4 minus 0 we can consider. So it will be 1.6 into 10 to the power of minus 2 divided by 4. It will be 0.4 into 10 to the power of minus 2. Right? So this is what? Rate of formation of NO2. Let it. Then rate of formation of O2. We need to find out the rate of formation of O2, rate of disappearance of N2O5, and rate of a reaction. Okay. Now see here. We can write rate of formation. So let's consider rate of formation of O2. That will be what? Change in concentration of O2 divided by change in time. Okay. So we need to find this with the help of this. What is given? Concentration of NO2 is increased. Can I write the rate of reaction as like, you see, rate of reaction can be written as, focus here, with respect to stoichiometric coefficient minus of 1 upon 2 change in N2O5 divided by change in time. It will be is equals to what? Plus 1 by 4, okay, of change in concentration of NO2 divided by change in time. Okay, that will be is equals to change in concentration of oxygen divided by change in time. Right? Now focus here. We are having this value, change in concentration of NO2 divided by change in time, which is given in the question, and we need to find out the rate of formation of O2. What is rate of formation of O2? Rate of formation of O2 is delta O2 divided by delta T. So see here. So rate of formation of O2, which is nothing but equals to delta O2 divided by delta T, and which can be equated from the rate of reaction as 1 by 4 times of change in concentration of NO2 divided by change in time. Okay, so we can write like 1 by 4. What is change in concentration is given? 1.6 into 10 to the power of minus 2 divided by 4 second, right? So we will write like this, 1.6 into 10 to the power of minus 2 divided by this 16. So we know this will be nearly what? 1.6, this is 16, 1 by 10. Okay, we can write it as 0.1 into 10 to the power of minus 2, or is equals to 10 to the power of minus 3. This is rate of formation of O2. So we got our second question also. Right. Now, next we want rate of disappearance of N2O5. Now see here. How will you write rate of disappearance? First write. Okay, write rate of disappearance. Rate of disappearance. Rate of disappearance of N2O5, and from the reaction it can be written as what? Yes, change in concentration of N2O5 divided by change in time. Okay, so right, it is nothing but delta N2O5 divided by delta T. Okay, this is the rate of disappearance. Now the point to be noted, very important here, is that okay, we can find out this change with the help of the rate of reaction. See, this is the rate of reaction. So equate with the help of rate of reaction. So from the rate of reaction we are having minus 1 by 2 change in concentration of N2O5 divided by change in time. It can be equated with what? 1 by 4 change in concentration of NO2 will be is equals to 1 by 4 change in concentration of NO2 divided by delta T. Now what we want? We want only this. So we will get like change in concentration of N2O5 divided by change in time with the minus symbol, which is nothing but the rate of disappearance of N25 will be is equals to what? Will be is equals to 2, that 2 will be multiplied here, divided by 4, change in concentration of NO2 divided by change in time, right? So we'll get 1 by 2 into this, already we know 1.6 into 10 to the power of minus 2 in 4 seconds. So we got like 1.6 divided by 8 into 10 to the power of minus 2. How many times? Or we can write like this, 16 divided by 8 into 10 to the power of minus 3, that is 2 into 10 to the power of minus 2. Okay, as we know it is a rate, it will be mole, liter inverse, second inverse, right? So this is rate of disappearance of N2O5. Okay, so we got our third question also, rate of disappearance of N2O5. What next we want? Next we want rate of the chemical reaction. The rate of chemical reaction. See, rate of any chemical, rate of a reaction can be written as minus 1 by 2 N2O5 by delta T, or 1 by 4 delta NO2 by delta T. You can take anything, or you can represent with the help of change in concentration of oxygen divided by change in time. So we will write like rate of reaction, rate of reaction, it will be is equals to what? 1 by, let's consider with respect to NO2 only. So that is 1 by 4, 1 by 4, change in concentration of NO2 divided by change in time. That will be is equals to 1 by 4 into 1.6 into 10 to the power of minus 2 divided by 4. So we are going to get same thing, 1.6 divided by 16 to the power of minus 2, that will be equals to 10 to the power of minus 3. Okay, this is 0.1. What will be unit for all of this? We know unit of a rate of reaction is what? Mole, liter inverse, second inverse. So this is how to calculate the rate of any chemical reaction, rate of formation, rate of disappearance, or rate of any reaction with respect to the stoichiometric coefficient. The point to be noted here, in case of formation or disappearance, we will never represent the stoichiometric coefficient. We will represent the stoichiometric coefficient only in case of complete or average rate of reaction. Thank you.